Next, let's talk about data acquisition, getting data. And I'll make a different lecture with more details on sources of data, but let's just talk about in general first. One of the most common things to do in GIS is, rather than creating your own data, that's more often we work with data that exists and try to do our best with what we can get our hands on. In the early days of GIS, there wasn't a lot out there, so there was a lot more of people scanning paper maps and building their own GIS data from scratch. But so much of it exists now with government agencies and others that for many of the things that we study, we can often find sources of existing data. So point being, acquire it if it exists, but you have some work to do. It doesn't automatically mean that it solves your problems. You need to evaluate that data. You need to examine it, make sure that it meets your needs. Is it accurate enough? Is it precise enough? And we need to look at, are the attributes the kind of thing, are the attributes useful? You need to look at the metadata, which is the documentation that comes with the data, to find out some information on who created the data, what time period does it cover, and so on and so forth. And in some cases, you may need to modify the data. Even if it is useful, you may need to still modify it to meet your needs. So various data sources are out there. In fact, there's numerous different kind of online warehouses of where you can look for data. And I'll include some of those in the class resources. I think I have some now. I'll check it, make sure it's up to date. I found this one that I wasn't even familiar with, called geoplatform.gov, where you can explore and look for map data. So primarily you're going to find these online. You're not going to be, not like in the ancient days where you're going to be trying to get mailed a tape or something. Now, if the data is extremely large, for example, if it was a bunch of, say, LiDAR data, which takes up just oodles and oodles of space, you may have to make arrangements to mail a hard drive and have that sent back to you. But that's usually, you're going to find your data online. Typically, these are from government agencies. The federal government and different agencies of the federal government maintain online geographic data. The U.S. Geological Survey, a federal agency, is one that's really kind of in a leadership role. They're the ones that have historically produced the base maps for the United States. So they maintain a lot of the both GIS. For example, they have digital elevation models. They have hydrographic information, transportation networks, various things. And many of these agencies, and sometimes you have ones that cover multiple agencies, have clearinghouses or places where you can find and download data. And sometimes you can find stuff from educational, non-governmental organizations. Often, if you get good at Googling for information, you can stumble across things. And there's also some companies just make commercial products, especially for if you're doing things like figuring out where to cite businesses, like data about population, incomes, that sort of thing, is something often provided by commercial companies that you would pay for. When you find data, you need to, and what comes in handy now is oftentimes you don't have to download the data and look at it in your GIS. There's oftentimes an online mapping platform that lets you view the information live online. But sometimes you do, if the data is just packaged up and doesn't have a display feature, you'll need to download it and then add that to your GIS and evaluate it. Does it look like what you expected? What I would like to do is find a place that I'm familiar with, zoom in on the data, and just evaluate it from what I know of that place, just to kind of see, is it what I expect to see there? And also, do the attributes, do they Are they meaningful, or do they make sense for what you're trying to do? And when you're evaluating it, you want to look at accuracy and precision errors. Those are similar concepts, but for example, here you have high precision. What you want to do is you want to hit this target. You want to be very accurate and you want to be very precise. And here you're both precise and accurate. This is accurate because they're centered around the target, but they're not as precise because they're not as grouped together. This one's precise, they're grouped together, but they're off target. So accuracy is kind of getting at what you're really wanting to do, and precise is the level of detail, essentially. So accuracy, how old's the data set? Is it out of date? Are there location inaccuracies because of the methods that were used to create the data? Did they goof up on the attributes? Did someone, did an intern type it up? And shouldn't blame the interns. Did someone, mistype information in there? Were there errors when they converted from one type of data to the other? And that's oftentimes metadata is meant to kind of tell you some about it should, although it seems like these days there's not as much detail as there used to be. There used to be a lot more emphasis on we took this data from here and we took it to there. But as much as you possibly can, you should read the documentation to just look for potential errors in the data. And then precision. What was the scale? How zoomed in were they when they created features? Were they zoomed way out so the stuff's all kind of not detailed enough, or were they zoomed very far in so it's very precise, or at least good enough for what you want to do? The same goes for like raster data, where you have grids. You can choose a different pixel sizes. Are the pixels very coarse, or are they very small pixels that are very detailed? You want to again, you want to get as detailed as practical, because you can generalize that later, but you can't go back to more detailed. And sometimes features are just hard to map. So for example, soil boundaries, maybe it's not that they did a bad, maybe they were zoomed in, it's not that they did a bad job, it's just that the nature of the feature itself was just hard to capture. And that happens sometimes as well. So metadata is the documentation that should come with data. It's defined as data about data. Who created it? What was the purpose? What scale was it created at? What's the extent? What are the attribute fields? And what kind of information is in those attribute fields? Are they numeric? What have you? And sometimes you might need to modify the data to suit your needs. And so there are GIS tools. For example, there's one to take a big data set and clip out a little part of it. That's a very practical thing that you may want to do, because you may be that you've obtained detailed soil data for the whole United States, excluding Hawaii and Alaska, but you only need it for Fresno County. You could take a shape of Fresno County, a GIS file with a county boundary, and only clip out Fresno County from that data set. That way you're using less resources while you're working with the data, and it's more practical to work with. You could also add custom attributes to what you're working with, or calculate new attributes. And so one thing I should mention about attributes, when I mentioned you can calculate certain things, you can also like add, if there's two different attributes, you could add them together and make that into a new attribute. You can do a lot of math with attributes as well. Or you might want to directly, if you find some spatial errors, or it's something, it's the best you have, but it's not good enough, you can directly edit data. You can make a copy of data and use that as something to work from.